Now, yesterday we have to discuss the feedback amplifier. Mm, Different type of feedback amplifier, that is positive and negative. In negative feedback amplifier, four type, that is voltage series, voltage shunt, current series, current shunt, feedback. So we have to discuss the block diagram of four type of feedback. That is covered. The effect of negative feedback on gain, bandwidth, input and output impedances we have to discuss. In this, we know that the gain formula for negative feedback AF equal to A by 1 plus A beta. So gain stability is increased and gain is decreased. That is the first point we have already discussed, and we derived these equations. So stability of the stability can be increased by using negative feedback. The product A beta is greater than unity, so AF is 1 by 1 by beta. So gain it depend only on feedback fraction beta, on the characteristic of feedback circuit. So it is beta network is a resistive network, therefore it is unaffected by changes in temperature, variation in transistor parameter and frequency. So the gain of amplifier is extremely stable. So second effect, it reduces the distortion by a factor 1 plus A beta. It can be proved mathematically. By applying negative feedback to the amplifier, distortion is reduced by factor 1 plus A beta. So total distortion, D is a distortion in amplifier without feedback. DF is distortion in amplifier with negative feedback. So with the negative feedback, DF equal to D by 1 plus A beta. This is a derivation for their distortion. So open loop distortion is divided by 1 plus A beta. That is a distortion is divided, noise also divided. NF equal to N by 1 plus A beta, where N is a open loop noise, NF is a closed loop noise. So noise in amplifier with negative feedback, NF is a noise with, it is divided by factor 1 plus A beta. It increases the input impedance and decreases the output impedance depending on sampling network and mixing network. Negative feedback is negative feedback on gain, bandwidth, input and output impedance. It affects on input output impedance. So input impedance of the amplifier is Z without feedback. ZF is with negative feedback. With negative feedback, input impedance is increased by factor 1 plus A beta. 1 plus A beta. So it is clear that by applying negative voltage feedback, input impedance of amplifier is increased by factor 1 plus A beta. A beta is must greater than unity, therefore input impedance very much higher. Output impedance is divided by 1 plus A beta, Z by 1 plus A beta, where Z is the open loop output impedance, ZF is open loop closed loop output impedance or negative feedback impedance. Beta is the feedback factor, A is the closed loop open loop gain. So 1 plus A beta with the lower value of output impedance. Amplifier is much better suited to drive low impedance load. Increase the bandwidth. By applying negative voltage feedback, the bandwidth of the amplifier is increased by factor 1 plus A beta. So BF equal to B into 1 plus A beta. So B is a bandwidth of amplifier without feedback. BF is a bandwidth. B suffix F is bandwidth of amplifier with a negative feedback. So A is the gain of negative feedback amplifier without feedback. Beta is the feedback factor. Next, it improves the frequency response. Feedback is usually obtained through the resistive network. Therefore, the voltage gain of amplifier is independent of signal frequency. Result is that voltage gain of amplifier will be constant over a wide range of frequency. So therefore it improves the frequency response of the amplifier. It increases circuit stability. So the output of our ordinary amplifier is easily changed due to variation in temperature, frequency and signal amplitude. This changes the gain of amplifier, resulting in distortion. However, by applying negative voltage feedback, voltage gain of amplifier is stabilized, accurately fixed in value. So these are the effect of negative feedback on gain, bandwidth, input and output impedance. So first one is gain stability, second reduction in distortion, reduce in noise, increase in input impedance, decrease output impedance and increase bandwidth, improves frequency response, increase the circuit stability. So these are the effect of the negative feedback. So comparison, we have to discuss the different type of negative feedback. We know that voltage series, voltage shunt, current series, current shunt. Voltage series, voltage means voltage sample, current means current sample, series means series mixing. In series input impedance is increased, in shunt input impedance is decrease. In shunt input impedance is decrease. So voltage series, the output impedance, voltage means voltage sample, so output is decrease, output impedance is decrease for voltage sample, and for a current sample the output impedance is increases. Similarly, input impedance for a series, voltage series, input impedance increase, current series input impedance increase, voltage shunt and current shunt input impedance decreases. Type of amplifier, voltage series called voltage amplifier, voltage shunt called trans resistance amplifier, current series called trans conductance, current shunt is called current amplifier. So amplifier bandwidth increases in all the cases. The bandwidth is increasing all the negative type of, distortion is decreasing all the type. The feedback signal at input port is feedback signal at input voltage. Series, in series we have to apply the voltage, in shunt we have to apply the current. So voltage shunt we apply the current at the input, current shunt we have to apply input as a current. Voltage series and current series we have apply input as a voltage. The sample signal at output port is, for voltage series sample signal is voltage, voltage shunt also voltage, current series and current shunt the sample is current to current. Now third chapter we have to discussing now, state the need for power amplifier. So we have to discuss the need for power amplifier. uh, what is a power amplifier, what is voltage amplifier, we have to discuss in this chapter. In all electronic system, last stage has to be a power amplifier. For example, public address system, it is a power amplifier that drives the loudspeaker. When person speaks into microphone, sound wave are converted into electrical signal. This electrical signal is very low voltage, less than millivolt. The signal is fed directly, cannot drive the loudspeaker to give audible sound output. If fed directly, cannot drive the loudspeaker to audible sound output. The voltage level of this signal is raised to sufficient high level, few volt, by passing it through the multi-stage voltage amplifier. This voltage is then this voltage is then used to drive or excite the power amplifier. The power amplifier is a capable of delivering power to the loudspeaker, delivering power to the loudspeaker. The loudspeaker finally convert the electrical energy into sound energy. The large audience can hear the speech, like music from the orchestra, CD player, other gadgets. So this is the definition. A transistor amplifier which raises the power level of the signal in audio range is known as transistor power amplifier. It is also defined as which convert the DC power to AC power and whose action is controlled by the input signal. So it provided a large amount of power to the load, such a loudspeaker, motor and power, called large signal amplifier. It is essentially in almost all electronic system with large amount of it is essential in all electronic system where large amount of power is required to be supplied to the load. It is used in power amplifier used in last stage. The power amplifier is more commonly known as audio amplifier. The audio power amplifier are used in public system, tape recorder, stereo system, television, radio broadcast. For example, multi-address system. Public address system consists of microphone, multi-stage amplifier, low power amplifier and loudspeaker. The microphone converts the sound wave into electrical, which is very low voltage. This signal is insufficient to drive the loudspeaker. Therefore, this signal is first raised to sufficient high level by passing through multi-stage amplifier. The signal is then used to drive the power amplifier because it is incapable of delivering large amount of power to the loudspeaker. So we have to compare the voltage amplifier and power amplifier. We have to compare voltage amplifier and power amplifier. The primary function of voltage amplifier is to raise the voltage level of signal. It is designed to achieve the largest possible voltage gain. Only very little power can drawn from its output. The power amplifier is meant to boost the power level of the input signal. This amplifier can feed a large amount of power to the load. To obtain large amount power at the output of power amplifier, its input signal must be large. That is why in electronic system, voltage amplifier invariably precedes the power amplifier. So power amplifier is called large signal amplifier. An important question arises: does a power amplifier actually amplifies the power? The answer is no. In fact, no device can amplify power. The idea of amplifying power contradicts the basic principle of physics. What a power amplifier actually does is that it takes power from the DC power supply connected to the output circuit and convert it into useful AC signal power. This power is to fed to the load. This power is fed to the load. Example, loudspeaker. The type of AC power developed at the output of power amplifier is controlled by input signal. The type of AC power developed at the output power amplifier is controlled by input signal. Thus, we may say that power amplifier is DC to AC power converter whose action is controlled by the input signal. Whose action is controlled by the input signal. So, characteristic voltage amplifier, power amplifier. Beta is the gain. For voltage amplifier, beta value is greater than 100. Power amplifier, beta value is very less. So what is a beta? Output current by input current. For voltage amplifier, input current is very less, so beta value higher. For power amplifier, input current is higher, so beta value is lesser. Beta value is less. RL is a load. RL is the load. The output impedance. The output impedance of voltage amplifier is higher, about 10 kHz. For power amplifier, it is 20 ohms. Input impedance actually low for the voltage amplifier, high for the power amplifier. Collector current is low for voltage amplifier, high for the power amplifier. Power output is high in a power amplifier, low in a voltage amplifier. Output impedance already we discussed, high for the voltage amplifier. For voltage amplifier we have to use the RC coupled. For power amplifier we have to use transformer coupled. So voltage amplifier applications. Voltage amplifier is used as a preamplifier. Voltage amplifier used as a preamplifier. Power amplifier used in last stage of multi-stage amplifier. Transistor configuration. Mostly used configuration is CE. In special case, CV configuration is used in a voltage amplifier. Power amplifier is used in last stage of multi-stage amplifier. Power amplifier is used in last stage of multi-stage amplifier. Transistor configuration. So voltage mostly used configuration is CE. In power amplifier, CE as well as CB. Heat production is more in the power amplifier because we are applying very high input impedance, input current. In voltage amplifier, it is very low. Cooling arrangement is required in power amplifier because it is a high current in the output, not required for the voltage amplifier. So these are the different comparisons. So heat sink is required for voltage power amplifier, not required for voltage. Another one is power dissipation is less in voltage amplifier, that is 0.5 volt, less than 0.5 volt. In power amplifier more than 0.5 volt. So next is a block diagram of power amplifier. It has the different stages, blocks. First stage is voltage amplifier, second is driver stage, third is a power amplifier stage. Output stage is in bracket power amplifier is directly connected to loudspeaker. So power amplifier is to amplify weak signal until sufficient power is available to operate the loudspeaker. So different power amplifier stages. Voltage amplifier stage. At input side we have to connect the microphone which convert our voice signal into electrical signal. Voltage amplifier stage we already discussed. It amplifies the weak signal from the microphone. Signal developed by microphone is very small and need sufficient amplification so to operate the output device. Therefore, raising the level of weak input signal. It is amplified in two or more stages. It is amplified in two or more stages, for which RC coupling is usually employed. So voltage amplifier stage we have to generally use RC coupled circuit. Driver stage. Next is driver stage. The stage between the voltage amplifier stage and the output stage is called driver stage. That is output stage and voltage amplifier stage. In between this stage is connected. The voltage amplification stage cannot drive the output to stage alone. The purpose of driver stage is to produce enough current gain. Purpose is to produce enough current gain in order to drive the output stage. Since there is a sufficient current gain, the driver stage produce considerable amount of power gain too. The driver stage provides power amplification as well as usual. So driver is in between two stages we have to connect it. Output stage is usually consists of power amplifier. It means for transferring maximum power to the output load. In order to transfer maximum at high efficiency, push-pull arrangement is employed in the output stage. Next is loudspeaker. It is a transducer which convert electrical audio signal into low sound signal. Electrical signal into audio signal. So voltage amplifier stage, input signal to the amplifier from source will vary extremely low, less than 10. Purpose is voltage amplification stage is to provide necessary voltage amplification to the input signal. Usually voltage amplification stage consists RC coupled amplifier, more RC coupled amplifier, two or more. Driver stage is standing between voltage amplification stage and output. Driver stage generally employs class A transformer coupled amplifier. So driver stage. It also provides impedance matching between voltage amplifier stage and output stage. Voltage amplifier stage and output stage. The output power from the driver stage is fed to the output stage. It is a final stage and feeds the power directly to loudspeaker or other output devices. Okay. Generally, voltage amplifier cannot work as a power amplifier. It cannot handle large power. However, transistor must have large power dissipation rating. If it is work in power amplifier circuit, practical rule is small single voltage. Power dissipation is less than 0.5 volt. Power transistor has more than 0.5 watt. So that is a that's why it cannot use. Another major problem is it has a wastage of power. The resistor RE has to be there in the circuit. If RE is absent, stabilization of the operating point become poor. This may ultimately lead to thermal runaway of transistor. So this is a class A power amplifier circuit. Generally class A power amplifier circuit with a resistive load. Generally we know already voltage amplifier is similar to like that, but difference is input signal. Here input current is more in this class A power amplifier. The question is whether the circuit would work as a good power amplifier if we replace the transistor with another higher power dissipation. We will see the circuit is no good as a power amplifier because the whole of the voltage VCC does not appear across the transistor. Under a question condition, DC collector current is ICQ. The voltage DC voltage available between collector emitter of transistor is VCQ equal to VCC minus ICQ into RC plus RE. This is the equation. The portion of the supply voltage is dropped in the resistor. The DC power that goes into transistor is VCQ into ICQ. This represents the effective DC input power to the amplifier. Only portion of the power can be converted by amplifier into useful AC power when the signal is applied. Now we can see why the circuit is not good power amplifier. The total DC power from the collector supply is VCC into ICQ. Out of this, only VCQ ICQ is the effective DC input power to the amplifier. The DC power from the collector is VCC into ICQ. Out of this, only VCQ ICQ is the effective DC input power to the amplifier because it at best that is the power that could be converted into useful AC power. The different of power is VCC ICQ minus VCQ into ICQ equal to ICQ into VCC minus VCQ equal to ICQ square into RC plus RE. ICQ square into RC plus RE. This much power goes waste into unnecessary heating the resistor. We can attempt to reduce this wastage of power. The resistor RE has to be there in the circuit because it is a part of the biasing. If RE is absent, stabilizing of operating point become poor. So that is a normal amplifier cannot work as a power amplifier because there is a power wastage in the resistive network collector. So different type of classify power amplifier, different types based on the frequency signal, audio, radio and video frequency according to period of conduction. The power amplifier is class A power amplifier, class B, class AB, class C, class D. Class A is a period of conduction angle is 360 degrees full cycle. Period of conduction means it working circuit. Sinusoidal signal is a 360 degrees, which is total cycle is we are applying at the input side. Class B, in class B, period of conduction angle is 180 degrees. That is a only positive half cycle is appear at the input, remaining part is removed. Class AB power amplifier. Class AB power amplifier, the period of conduction angle is greater than 180 degrees but less than 360 degrees. Class C power amplifier, period of conduction angle is less than 180. That is another one according to configuration: single-ended power amplifier, push-pull power amplifier, complementary push-pull power amplifier. Now we have to define the efficiency of power amplifier. Conversion efficiency. We have to define conversion efficiency. Average AC power output by average DC power input to transistor. PAC by PDC is called the conversion efficiency. Efficiency also called conversion efficiency of, this is also called collector efficiency. The efficiency of amplifier represents the amount of AC power delivered or transferred to load from the DC source. Actually here we converting the DC VCC into ICQ is converted into AC useful form by controlling the input AC signal. So this is called efficiency. So expression for efficiency of power amplifier under zero signal condition. Zero means we are not applying any signal, only DC we are applying. Let ICQ be the collector current corresponding to the operating point Q. Under this condition, DC power input supplied by collector power supply is given by collector given PDC is VC. Without input AC signal, PDC is VCC into ICQ. For an alternating output voltage and output current swing, we can write output voltage and current swing Vm equal to Vmax minus Vmin by 2, Im equal to Imax minus Iminimum by 2. The RMS value of alternating output voltage and current, we have to convert it into RMS. Vrms equal to Vm by under root 2 equal to Vmax minus Vmin by 2 root 2. Similarly IRMS Im by under root 2. So substitute this AC output power is given by Vrms into IRMS. So we have to substitute this. PAC is Vmax minus Vmin into Imax minus Imin by 8. We can write. And we know that DC is VCC into ICQ. So maximum. So using this equation, we can represent using equation 1 and 6. We can write overall efficiency is Vmax minus Vmin into Imax minus Imin into 8 VCC ICQ into 100. Now we have to discuss the distortions is there in power amplifier. Amplitude distortion, frequency, phase crossover distortion, out of band distortion, in band distortion, out of band distortion and in band distortions, various type of distortion. So what is distortion? Whenever we applying some voltage at the input side, the output has the same shape as the input without any disturbance. Loss of the signal is called a distortion loss. When it has some distortion, it is a distorting the input signal. So non-linearity of power amplifier effect or modulated signal are out of band distortion in band distortion effects. The difference between output waveform and input waveform in an amplifier is called distortions. We know amplitude distortion, also called non-linear distortion, crossover distortion. There are different type of distortion is there. The peak value of output waveform of the power amplifier clipped up due to shift in operating point. Due to change in operating point, the output peak value has been cut up, clipped up. So output waveform is not exactly same as input. This type is called amplitude distortion. So it will reduce the efficiency. Crossover distortion is caused by non-linearity of input characteristic of transistor. Transistor do not turn on at a zero voltage applied to the emitter junction, but only when emitter junction is forward biased by cut-in voltage. The cut-in voltage is 0.3 for germanium, 0.7 for silicon. Harmonic distortions, phase distortions, these are the frequency distortions. Many of the input signal that practical amplifier will amplify consist of required signal waveform called fundamental frequency plus number of different frequency called harmonic superimposed on it. New frequency are produced in output which are not present in the input. The shape of output signal is not same as the input, called harmonic distortion. Phase distortion is caused due to different frequency component undergoing different delay in process of amplification. This distortion is also called delay distortion. Because it caused due to the time delay between the input signal and its output signal. So these are the different type distortion. Now we have to discuss the class A power amplifier with a resistor load today. So this is similar to CE amplifier. Similar to CE amplifier. In this, collector current flow during the full half of the input signal. Class A amplifier, collector current flow 360 degrees. It has low efficiency is 25 because amplifying device use power for full cycle of input signal, but good signal reproduction and linearity. The power amplifier is said to be a class A amplifier if a operating point and input signal are selected such that output signal is obtained for full input signal. For this position, Q point is in mid of the load line. The single-ended, it is a single-ended class A power amplifier with a resistive load RC. Transistor operate in active region, hence amplified power output appear across load resistor. The current and voltage waveform of class A operation as shown in the output characteristic. This is the output characteristic. IC versus VC. It's IC current and VC and voltage as total cycle is appear at the input, so output also total cycle appear. So IC versus VC. So IC has full current swing. IC max, IC min, ICQ is the operating current which is at midpoint of Q point. VCQ is the voltage at midpoint. VCQ ICQ gives the operating point in this output curve. Now working in order to have maximum AC output power, the peak value of collector current due to input AC signal alone should be equal to zero signal collector current. To achieve this, operating point is located at center. By adjusting R1, R2, by adjusting R1, R2 and RE in this circuit, we select the operating point in midpoint. When input signal is applied to the base of the transistor, through the coupling capacitor C in, the forward bias of the base emitter junction will vary between maximum to the minimum. The forward bias of base to emitter current is vary from maximum to minimum. The base voltage varies as per the signal voltage Vi input. As a result, base current also varies. Base current varies according to collector current will vary. Variation of collector current, collector voltage appear across a load resistor or RL. Result is amplified AC voltage appear across the RC RL. The amplified collector current flows 360 degrees of the input signal. For full input signal, full output cycle is obtained. Here a signal is faithful reproduction at the output without any distortions. This is an important feature of Class A operation. So efficiency of Class A operation is very small. For expression for power output, the power output of the circuit is, what is the power output of this circuit? Output power and input power we have to calculate. So two type of operation, DC operation and AC operation. We have to calculate the efficiency of the circuit. We know already discussed the power is AC power, we already know. DC power is VCC into ICQ. Our overall efficiency is Vmax minus, efficiency equation is Vmax minus Vmin into Imax minus I by 8 VCC ICQ into 100. It is 100. For DC operation, we apply VCC resistance R1 R2 decide the DC base bias current ICB. ICQ is a beta time ICB. Corresponding zero signal collector to emitter voltage is VCC minus ICQ into RL. Q point can be defined as Q VCQ in comma ICQ. When AC input signal is applied, base current varies sinusoidal. Assume that non-linear distortion is absent. The nature of the collector current and collector to emitter voltage also varies sinusoidally. It may be noted that collector to emitter voltage varies opposite shape to the collector current. Whole collector to emitter voltage is maximum Vmax when the collector current is minimum, vice versa. By varying output voltage and output current deliver AC power to the load. Advantage of this circuit is simple and design implement. Load is directly connected to collector circuit, hence the output coupling element is not required. This makes the circuit cheaper. Disadvantage, very low efficiency, biggest disadvantage. Load resistant directly connected to collector circuit varies. Quotient collector current ICQ. This causes considerable wastage of power. Output impedance is high, hence this circuit cannot be used for low impedance such as loudspeaker. So output impedance is high for the circuit. Efficiency of amplifier represents the amount of AC power delivered or transferred to the load from the DC source. We know this is overall efficiency. From the figure we have to maximum Vmax, Vmin, Imax, I mean we have to calculate it. So from the circuit we have to substitute that. We know the equation Vmax minus Vmin is 0 generally. Vmax is VCC. Vmax is VCC. Here Imax is 2 times ICQ. Imin is 0. Imax is 2 times ICQ. So ICQ is the 2 times. We have to substitute and calculate. This is the 20%, 25% efficiency. This is only difference. Vmax is most greater than V minimum. We can neglect also this. So we can say this is a, in case of rest to load, collect VCC equal to Vmax. From this waveform we have to calculate the efficiency. Next class we have to discuss the transformer coupled amplifier.